Hello, welcome student to our channel The Physics Point. In the previous lectures, we have just discussed this relationship between the electric potentials and electric field. The electric field is produced due to the electric charges. There are positive electric charges or negative electric charges around these electric charges. Consider the positive charge plus Q is placed at a point, a certain point. This point is called maybe A. Then the electric field is produced surrounding to these charges. This is known as electric field. And electric potential, what is the potential? To potential, it is the work done by the charges to bringing these certain charges from the infinity position to the electric field to the another charges. This is called as the electric potentials. In the previous lectures, we have just discussed the relationship between the electric potentials and electric field. In these lectures, we have started discussions of the electric potential due to a point charge. Please take the heading. These are electric potentials. Electric potential due to a point charge. Electric potential due to a point charge. This is the explanations which are started discussions in this lecture. Electric potentials. Electric potential, it is the work done by the charges, by the unit charges which are brought from the infinity to the certain positions or infinity to the electric field of another atom. This is these things, and these electric potentials are produced due to a point charges. Okay, let's start discussions with help of the certain diagrammatical representations of the charges. Consider a charge. Consider a positive charge plus Q which are placed at a point O. Consider this is the positive charge which are placed at a point O. The heading, that is, consider a charge placed at O, at point O or at O. Let us another one positive charge or unit positive charge which are bring from the infinity to that points, and this point is known as a point A. This is our pointer A, and we want to bring a smallest positive charge from the infinity to this pointer, that is point known as point A. And let, let's take the explanation. Let positive charge bring or bring at pointer A from infinity. A positive charge is bring at the point A from the infinities. Let us consider one of, I will take on one of the smaller, another one positions or another one point. This point is known as pointer M, and another one point, this point is known as point N. This M, a point, there are midpoint between these points or intermediate point, not exactly midpoint, but there are present intermediate point of the path which are comes from this which are due to from these charges which are brings from the infinity to the point A, and the distance between these point O to the point M is x. The distance between OM is a x, and these charges are traveling with a certain velocities, sorry, not velocity, certain displacement. This displacement is known as dx, which are comes from the m to n. When these particles is come to m to n, they are displaced certain displacement, that is dx. We know that the work is done when these positive charges comes from the m to the n. Before the discussions of work done, we must know the electrostatic force which are acting on the smallest positive charge. This electrostatic force is the magnitude of electrostatic force E bar. This is equal to F is equal to 1 upon 4 pi epsilon 0 Q upon x square. The electrostatic force, Coulomb's law, they are explained by this Coulomb's law. The force of attraction between or repulsion between these two charges is directly proportional to the product of the charges. Q, this is one charges and this is one another unit charges. One into anything is gives anything. Any numbers, any values multiply with unity, that gives these same numbers. Then the divided by universally proportional to the product of square of distance between these two charges. Distance is q to m, these are x. Okay, now done work done w, the work done is equal to force into displacement, force into displacement. The work done is equal to force into displacement. Then the W is equal to minus F into dx. Dx is the smallest displacement of the charges which are displaced upon pointer M to the pointer N. Point M to the point N. And why we are taking the negative charges? Because these directions, I will be shows the arrow, the directions of electrostatic force. The electrostatic force, direction of electrostatic force and the directions of the displacement are opposite to each other, and this must reason we want to take in the negative sign according to the F. Then the total work done dw is equal to, we must be taken integrations of these equations. Work done w is equal to integrations of minus f into dx. And these charges r comes from the infinity to the radius at the pointer r. Then this point we are taken infinity to the r. The limits of the integrations, there are infinity to r. But the minus signs, let's put the value of force as well as displacement, that is infinity, this is not a minus, infinity to the r. Then minus 1 upon 4 pi epsilon 0 into q upon x square into dx. This is our answers, or this is the value of force, and these are also displacement and the negative sign as it is. These all things, these all such things are constant. We could not be taken a derivative and integrations of constant, then the taken outside, the w is equal to minus of 1 upon or q upon 4 pi epsilon 0 and the integrations of 1 upon x square into dx. This is the value of integration. These all such things are constant. Due to this constant, we are must be taken outside, and remainings are only x. X is only variable value because the displacement, the positions, the unit charges will be changes their positions, and if they changes their positions, they will be changes the difference between their positions to the origins of the positive charge, changes their distance. For these reasons, we must be taken the integrations of only 1 upon x square. The limit of integration is infinity to the r. Okay, this is all about such basic things. Now we must be solve the integrations of these things. Okay, let's solve the integrations of this thing. The W, total work done by the charges, they are by the unit positive charges when they are come to infinity to nears to the origins or the pointer O. Okay, these are minus q upon 4 pi epsilon 0. We know that the derivative of 1 upon x is equal to minus 1 upon x square. For this reason, we are just to multiply this minus sign in inside. Then these are infinity to r 1 upon x. We know that when we are applying the limit, the q upon 4 pi epsilon 0 into, we apply the limit first upper limit minus of lower limit. This is such things which we are discussed in the previous. These are all useful, or this is the rule of integrations. We must applying first higher limit minus of lower limit. These are the value of integrations of the 1 upon x square with respect to dx, and the limit of this integration is infinity to the r radius. Then applying the limit, the 1 upon r minus 1 upon infinity, higher limit lower minus lower limit. Then the work done W is equal to 1 upon 4 pi epsilon 0 into r. Why we are taken r? Because 1 upon infinity must be 0. Then we must be calculated the work done q upon 4 pi epsilon 0. This is the work done. It means electric potentials. We are definitions, just to study the definitions of the electric potentials. The electric potential, it is the work done by the unit charges, which are brought from the infinity to the in the electric field, and this is the work done. It must be electric potentials, and this is due to the point charges, is plus q. And the electric field are produces positive around the positive charges. It means the electric potentials, the positive electric potentials are produced due to the positive charge, and negative electric potential is produced due to the negative charge. This is the most important things which are asking how many times in the exam or MCQ types. What we are discussed, the electric potential due to the electric charges. Consider we taken one of the smallest point, positive charges plus q at the point of O, and let another one positive charges are brought from the infinity to at the point A, and the point M is the intermediate point of that of the path of moving of that positive charges. Then we know that we want to finding the electric potential must be, the electric potential is the work done. When we are finding the work done, we must be want to the forces which are acting on these charges, and the forces which are acting on the electric charges is known as electrostatic force. The magnitude of electrostatic force is F is equal to 1 upon 4 pi epsilon 0. Then work done is equal to minus F into dx. It is the smallest displacement of that charges which are moving m to n. And why we are taking the negative sign? Because the E bar is the electrostatic force which are away from the point O, and displacement of the charge which are comes towards to that point O. Due to this, we are taken a negative signs, and we want to finding the total work done on the charges are just integrated and find the final values. And one two sentence I will be said after the completion of this derivative. The negative charges are produce the negative electric potentials, and positive charges are produce the positive electric potentials. Okay, we want to stop here, and the next concept will be discussed in the next lecture.